Hello student, let's continue the lesson. Now we go for another property of the Laplace transform, but now we would like to use the second shift theorems. So the theorem 3.3.3 is state that if you have one function of ft, then you Laplace it, then you will get the function in terms of s. But if you have two combination of function, which is we have the function of f and another function of u, and then we can Laplace it using the second shift theorem, you will get exponent negative as, and then the output of the Laplace on the function of ft, just like this. So you will have over here the two function, which is f and u, but you need to make sure that the element of f and u are in terms of t minus a. So you will get an a from here, and then the answer is exponent negative a. You take it from here, and then the yield of the Laplace transform of ft, which is you will get fx. So now let's go to example. If you have one function, then that function is the unit step function. So you have this one and this one. So we call this one as a f t minus a, and then here is u t minus a. Okay, so look at the element inside here. So we have the same one over here. So no need to do modification, because of you will directly get what is a. So the a over here is 3. So the a over here is 3. So what is your ft? So you need to find your ft. Your ft is the one that there is no a. You just neglect the a, and then you got your ft. So your ft now is 3t power of 3. So now from these properties, it said that if you already have your a, so the answer for the first term is exponent negative as, and the Laplace of the ft. So when you Laplace of the ft, you will get 3 factorial and s power of 4, which is give you 6 s power of 4. So your final answer from this theorem is the combination of exponent negative as with the fs. So you already got your fs over here. You just combine between the exponent. So exponent negative, okay, exponent negative as. So your a is 3, exponent negative 3s, and your fs is 6 over s4. So your answer is exponent negative 3s and 6. Just combine it. So you will get this answer. Alright. So now let's go to exercise. Okay, let's say if you have the equation to transform, to find the Laplace transform of t u t minus 5. So as I told you previously, the first term over here is representing your ft, and then here is your t. There are two functions over here, but your function of u is in term of t minus 5, but does not happen in ft. So what you need to do is you need to modify that equation so that that equation, that terms is in term of t minus a. So now your t must be equivalent with the one that having in u. So the equivalent one is t minus 5. But if you are make it minus 5 happen in your equation, you need to plus v5 so that so that you are not making the new things on the equation, and the term u is remain. So look at here. So this is your ft now. So this is the existing one. Because when you are calculating the terms over here, it's basically the same with the equation. We just make it general so that we can use the second shift theorem. So now your ft is without a. This is your a. So now you can calculate. You can identify your a. Your a is 5. And then what is your ft? So as I said to you, your ft is the term t without a. So without a, this one, so it remain t plus 5. So from here, you can find your fs over here by Laplace that equation. So what you will get? You will have here t1 factorial s power of 2, okay, s power of 2, here is factorial, so please be careful, okay, please be careful, we have 1 factorial s squared, and then for 5 with plus with 5 over s. So you may look at the table, you may look at the table. So your final answer for Laplace between t minus 5 over here is the combination of the fs and exponent negative a. So your a now is 5 and you have s over here. So you are calculate 1 factorial, you got 1 over s squared over here, and then you have 5 over s over here. So this is the answer. Very direct. Very direct equation. Okay, I make it summarize for you. The first thing first, when you want to use the second shift theorem, what you need to do is you need to look at the equation. You need to look at the equation. The equation must be tally here. So the first one is your function of f must be the same term with the function of u. T minus a, and we have t minus a. So when you already have the consistence here, so you can bring a over here, and then the answer must be the combination of the exponent negative as with the output that you transform the function of ft. Alright, so I hope you understand, and then we will continue again in the next property.